Hello everyone. Now we are starting next chapter of Unit 3, that is Media Access Control. So what is media access control? We can classify the network into two categories, the point-to-point network and broadcast network. In this chapter, we are going to discuss the broadcast network and their protocol. The broadcast channels are also called as a multi-access channels or the random access channel. In broadcast network, the most important point is the criteria by which we decide who is allowed to use the common channel when more than one user want to use it. Protocol is used to make this decision. Such the protocols belongs to the sublayers of data link layer called as a MAC, that is media access control sublayer. And the MAC sublayer is a very important in the LAN because it is a broadcast network. Next is MAC and LLC sublayers. As shown in the figure, the layers of OSI model partial to show the position of the MAC and the LLC sublayers. The broadcasting protocol corresponding to the lower layer that is layer 1 and 2, the OSI model is shown in the figure. The LAN protocol with the OSI architecture, the architecture was developed by the IEEE 802 committee and it has been accepted the LAN standards. It is called as a IEEE 802 reference model. Let us discuss the model layer by the layer. The function of the media access control, that is MAC sublayer. To perform the control the access of the media, it performs the unique addressing to the station directly connected to the LAN and detection of error. The function of the LLC, that is logical link control sublayer, error recovery, it performs the flow control operation and user addressing. Next is channel allocation problem. In the broadcast network, the single communication channel is to be allocated to one transmitted user at a time. The other user connected to this medium should wait. This is called as a channel allocation. There are two different schemes used for the channel allocation. First is static channel allocation in the LANs and MANs. Second is dynamic channel allocation. So first is static channel allocation. The traditional way of allocating a single channel among many users is means of the frequency division multiplexing, that is FDM. The frequency division multiplexing FDM and the time division multiplexing, that is TDM, are the example of the static channel allocation. In this method, either a fixed frequency band or the fixed time slots is allocated to the each user. Either the entire available bandwidth or the entire time is shared. The problem in this method is that if all n number of users are not using the channel bandwidth is wasted, and if there are more than n users who want to use the channel, they cannot do so for lack of the bandwidth. For the small number of users or the light traffic, the static FDM and the efficient method of allocation, but its performance is poor for a large number of users, bursty and heavy traffic. The static channel allocation has a poor performance with the bursty traffic, and hence generally dynamic channel allocation is used for the computer network, whereas traffic is bursty in the nature. Next is dynamic channel allocation in LANs and MANs. In this method, either a fixed frequency or the fixed time slot is not allocated to the user. The user can use the single channel as per its requirement. Following assumptions are made for implementation of this method. First is the station model. This model consists of the n independent station as the PC computer which can generate the frame for the transmission. The station model assumes that each of n station independently produces the frame. The probability of producing a packet in the interval ID where I is the constant arrival rate for the new frames. Second is single channel. A single channel is available for the all communication. In this allocation, all stations are equivalent and can send and receive on that particular single channel. That is single channel assumption. Next is collision. If a frame are transmitted at the same time by the two or more stations, there is overlap in the time and resulting signal is garbled. This is called as a collision. That is If two frames overlap in the time wise, then that's collision. There are collision is an error. Both frames must be retransmitted. Collisions are only possible error in the dynamic channel allocation. Next is time, that is continuous or slotted time. There is no master clock used to divide the time into the discrete time intervals. So the frames can begin at any random instant. This is continuous time. And for slotted time, the time is divided into the discrete time slot. Time can be divided into slotted and continuous in dynamic channel allocation. And last is the station, that is carrier or the no carrier sense. Station sense channel before transmission, they are directly transmitted without sensing the channel. The station can sense the channel if it is busy before they try it or they send data over that channel. Next is multiple access. When a number of stations use the common link of communication system, we have to use a multiple access protocol in order to coordinate the access to the common link. There are three techniques used to deal with the multiple access problem. First is random access, second is controlled access, and third is channelization. And first is random access. In the random access, the technique says no control station. Each station will have the right to use the common medium without any control over it. With increase in the number of stations, there is increased probability of the collision and the access conflict. The collision will occur when more than one user tries to access the common medium simultaneously. As a result of such collisions, some frames can be either modified due to error or destroyed. In order to avoid collision, we have to set up a procedure. First is multiple access, carries the carrier sense multiple access, and that is divided into two parts, that is CSMA CD, that is CSMA CA. The first method evaluation ladder is known as Aloha for a simple procedure called as a multiple access. It was improved to develop the carrier sense multiple access. The carrier sense multiple access involves into two methods normally, CSMA CD, that is CSMA with the collision detection, and the CSMA CA, that is CSMA with collision avoidance, which avoids the collision. So next point is multiple access Aloha system. The system in which multiple users share a common channel in the way that they can lead to conflict, widely known as the contention system. The Aloha system is the contention protocol which was developed at the University of Hawaii in the early of 1970s by Norman Abramson and his colleagues. The Aloha system has two versions, pure Aloha and slotted Aloha. So first is pure Aloha. As the name suggests, it works only on simple basic principle. Essentially, it allows for any station to broadcast anytime. If two signals collide each station simply waits a random time and try again. The collision are easily detected. When the central station receives the frame, it sends the acknowledgement on different frequency. If a user station receives an acknowledgement, it assumes that the transmitted frame was successfully received, and if it does not get any acknowledgement, it assumes that the collision has occurred in the ready to retransmit. The advantage of pure Aloha is the simplicity in the implementation, but its performance becomes worse as the data traffic on the channel increases. Next is protocol flow chart for the Aloha. A station, a basic explanation of this protocol flow chart is a station which has frame ready for transmitting will send it, then it waits for the some time, then if the receiver sends the acknowledgement, then the transmission is the successful. Otherwise, the station use a back-off strategy and will send the packet again. After sending the packet many times, if no acknowledgement, then the station aborts the idea of transmission. Contention system. The system in the multiple users share a common channel in such a way that they can lead to the conflict or the collision are known as a contention system. Whenever two frames try to occupy the channel at the same time, there is a bound to be collision and both will garble. The retransmission is the essential for the destroyed frame. Next is efficiency of the Aloha channel. Efficiency of an Aloha system is the fractional of all transmission frame which escapes the collision, that is, do not get caught in the collision. Consider infinity number of interactive users at the computers. Each user is either typing or waiting. Initially, all of them are in the typing state. When the user type a line, the user stops and wait. The station then transmit a frame containing this line and check the channel to confirm the success. If it is successful, then the user will start typing again. Otherwise, the user will wait and its frame is retransmitted many times till the sending is successfully. So how we are going to calculate the frame time? Let us the frame time is defined as the amount of time required to transmit a standard fixed length frame is frame time is equal to frame length divided by bit rate. Next point is slotted Aloha. To overcome the disadvantage of pure Aloha system or low capacity, Robust published a method for doubling the capacity of the traffic on the channel. In this method, it was purposed on that the time will be divided into discrete interval and each interval correspond to the one frame. This method requires the user agree on the slot boundaries. In the method of achieving synchronization, one special station emits peep at the start of the each interval like clock. This method is also known as the slotted Aloha system. Collision occur if any part of the two transmission overlaps. Suppose T is the time required for the one transmission and two stations must transmit. The total time required for the both stations do the successfully is 2T. In the case of pure Aloha, allowing the station to transmit at arbitrary time can waste up to 2T. As an alternative to the slotted Aloha method, the time is divided into the intervals slotted of the T units each and requires each station to begin each transmission at the beginning of the slot. In other words, even if the station is ready to send in the middle of slot, it must wait until the beginning of the next slot. In this method, the collision occur when the both stations become ready in the same slot. The slotted Aloha is the discrete time system, whereas the pure Aloha is the continuous time system. The vulnerability period has been reduced the half of that pure Aloha. Then the throughput of the slotted Aloha is given as the S or throughput is equal to G e raised to minus G. The maximum throughput corresponds to the G is equal to 1 and then it is given by the 1 upon E is equal to 0.368 as shown in the example. Next is comparison between the pure Aloha and slotted Aloha. A mathematical model can be created for the relationship between the number of frames transmitted and the number of frames transmitted successfully. Let the G be represent the traffic measure as an average number of frames generated per slot. Let S be the successful rate as an average number of the frames sent successfully per slot. The relationship between G and S for the both pure Aloha and slotted Aloha is pure Aloha S is equal to G e raised to 2 minus 2G and slotted Aloha is S is equal to Ge raised to minus G, whereas the mathematical constant G is equal to 2.718. From the above equation, the successful rate of curve of pure Aloha and slotted Aloha can be plotted. The both graph have the same shape, but if G is small, then S means if the few frames are generated, few frames will transmitted successfully. If the G increases, so does S, but upon the certain point, as the G continues to increase, the S appropriate. The zero means that if more frames are generated, there will be more collision and successful rate will fall to zero. So basic comparison of this slotted Aloha and pure Aloha is time slot. In pure Aloha, any station can transmit data at any time. In slotted Aloha, the data will send at the beginning of the time slot. The time in the pure Aloha, time is continuous and it is not globally synchronized, and in slotted Aloha, time is a discrete and it is globally synchronized, so that one user can send the data at the beginning of that particular time slot. Vulnerability time, the vulnerability time is equal to 2 is equal to 2 into tt, and vulnerability time in slotted Aloha into is equal to tt. That is, pure Aloha is exactly double have vulnerable time. Next is probability. Probability of successful transmission data packet is g into e raised to 2 minus 2 raised to g, and probability of successful transmission of the data packet in slotted Aloha is equal to g into e raised to minus g. The maximum efficiency of pure Aloha is 18.4%, and the in slotted Aloha maximum efficiency is 36.8. that is exactly double to the pure Aloha, and the number of collision will reduce the number of the collision in pure Aloha, as in slotted Aloha reduces the number of collision to half, the half, thus the efficiency is double than the pure Aloha. Thank you.